So let's talk about how to support SSL. If we come back over to Visual Studio, we'll see that we have the solution pretty much as it was at the end of Module 2, with the exception that we've actually implemented a couple of the operations on our API that would have been duplicative to show you. Specifically, this was the post and delete on the diaries controller. If you want to follow along, you'll want to go get the after from the Module 2 directory of the examples if you have access to them. So we want to have a way in our web API to force the website to use HTTPS. Now, it may be that you've already configured this on the server and you've already installed certificates on the server to support that. I'm going to assume that you have already figured out how to get certificates onto your IIS server and that you don't need help with that. There are some other videos here on Pluralsight that can help you with that. That's outside the scope of what we're trying to do here. We want to talk about cases where we want to make sure that web API itself uses HTTPS even if the server isn't configured to force it on the entire website. Best case scenario is that you're just going to support it on the entire website, but there may be cases where you want to just apply it to either the entire web API or individual operations on the web API. The way we do this is with filters. Now, in web API, there's this notion of something called a filter. This is an attribute that you can apply onto parts of the web API project to say that when this item is processed, this is going to be some code that is going to be called during the pipeline of the request. So by creating a filter, we're going to have the opportunity to be called during the processing of the web API request. The particular type of filter we're about to build is going to be called before the actual web API code is executed. So let's create a new class, and let's call that Require HTTPS attribute. This is going to be an attribute that we can then apply to either parts of our web API or the entire set of web API calls to force it to require HTTPS. And in our particular case, we're going to tell it to reject the call if it's not HTTPS and give some header information to tell browsers to go ahead and switch to HTTPS. In order to do this, we need to derive from a filter-based class. They all implement an interface called iFilter, which is in the system.web.http filters. And this filter is just a simple interface that all the real functionality is derived from. So instead of implementing iFilter ourselves, we're actually going to use authorization filter attribute. This is a filter that's going to allow you to get called when a particular call is about to be authorized. So we can override the onAuthorizations call. And this onAuthorizations call is expecting us to either allow the call through by simply returning through, or by injecting into the response, creating a new response that is going to say that something is wrong, most notably not authorized. This action context is a class that contains different parts of the actual operation. Includes access to the request and a response object so that we can read what the request is and make decisions about the response. And that's in fact what we want to do here. We want to look at let's go ahead and get the request out. We're going to look at the request URI and look at the scheme to see if this scheme is HTTPS. We can test with the constant of URI.URI scheme HTTPS. If it doesn't equal HTTPS, we're going to want to present to the user just a tiny piece of HTML that represents that something is wrong. And so I'm just going to create a little HTML string here that says HTTPS is required. So a tiny piece of markup that we're going to include in the response. What we do here is going to be different whether it is a GET or a non-GET request. So let's go ahead and ask if the request.method, which is the string of the method. Don't ask me why it's method.method. I'm not a huge fan of the way they do that. If it's a GET, then we'll do some work. Otherwise, we'll do some other work. And so let's start in the else first. Here we can simply say action context.response equals request.create response, and notice it's not showing up in IntelliSense. That's because we're actually missing a namespace declaration where the extension method for request.create response is included, and that is system.net.http. We include that, then we can now see that we're getting IntelliSense for the extension method of create response. And we're just going to want to set the status here and add that namespace of system.net to not found. And then we're going to need to set the response.content to that string that we created with the HTML. So we're going to say new string content. We're going to pass in HTML as the string of the content. We're going to give it an encoding. Bring that namespace system.text in, UTF-8. And then the media type for HTML is text/HTML. By doing this, it's going to set all the appropriate headers on our response for us. But again, remember, this was only if we weren't doing a get. What we're going to do for the get is pretty close to it, but the status code we're using is actually a little different. It's going to be found. So someone makes a GET request, and if they're using HTTP, we're going to say, hey, we found this. This is a valid URI, but we're going to give you some more information about where it's actually found. So this is different than OK in that it's going to tell browsers and other people interested that where the object is located is under HTTPS, not under HTTP. Now that we've created the response and the content for found, we also want to include one more piece of information. And to do that, we're going to create a new URI. So let's go ahead and create a URI builder, which is a class that will allow us to put together a URI. And we're going to pass in a URI as the base of the new URI. And we're going to get that from the request. We're going to use the request's URI as the basis for our new URI. So we want everything that is inside the existing request that they've asked for, but we want to make a couple of changes. So we want to go to the builder and say the scheme is going to be URI.https. We're changing it from HTTP or whatever scheme it was using to use HTTPS instead, and then we can do the same with port, specifying that it's going to be port 443 or the SSL port. Now that we have the URI ready to be used, we want to use it someplace. And what we want to do is go to the response headers, and there's a header called location that we want to set with this new URI. Let's see if that builds. Yep. And now that we have the attribute built, we want to use it. We want to put it on different objects to specify that we want to require HTTPS in certain cases. So let's open up the food controller for a minute. And we could actually add it here. We could just say require HTTPS, and this would inject that filter into the pipeline when we're making any calls to the food controller. It would know that if I'm doing a get on foods, to go ahead and call this unauthorized first. It may be that you want it on some controllers and not on others, or even on some methods and not others. In the case of require HTTPS, we actually want it for the entire web API. So instead of trying to make sure that we haven't messed up by missing it on a controller, we can actually add it directly in the web API configuration. Here at the end, we can simply say config.filters.add and create a new instance of our require attribute. And in this case, this will be added to the standard set of filters for every single call coming into web API. So this is really common to make sure that your API is using SSL so that regardless of the kind of data you're dealing with, that you're going to be using SSL in all cases. Let's see this work. So I'm going to pop over to Fiddler. Let me actually copy the web address here for our project, and let's go ahead and navigate to any of our APIs. So I'm just going to go to nutrition foods. And if I just issue this get against our food API, we're going to see a couple of things happen. Our call to food nutrition is going to give us a 302. 302 is found in HTTP status codes. So Fiddler found our foods because what we did was we actually returned that we found it, and then we returned the location as the new location. And notice the only difference is it's HTTPS. And we can also see that that body of the message was sent back as HTTPS is required, so that if this were shown to an actual user, if we were doing this directly in the browser, that they could actually read that. It wouldn't be a very pretty page, but it serves the process. But because we set 302, the browser will do the same thing that Fiddler is attempting to do, and that is immediately issue the call to HTTPS. It took that location header, let's look at raw, and it attempted to find this. Now, we don't have HTTPS configured on our test server. We're just using IIS Express, and you can set that up to use a locally signed certificate and such. I haven't set all that up because that can be a little cumbersome, but I just wanted to explain what was going on. So it's attempted to get this, and then it's rejected because there is no one listening to 443 on this particular machine. And the same thing will happen in the browser. If we head over to Firefox, and we go ahead and put in an API for nutrition foods, it's showing us to the user not that HTTPS is required, but in fact it's showing us an unable to connect. And why is that? Because when we requested it, it actually switched us over and changed the URI to the HTTPS because it got the found header plus the location, so it knew where it was supposed to be located at. Normally, when I'm building an API, I will do if not debug, so that this isn't actually turned on in my test builds. I can go ahead and go about the business of testing my application without any SSL, but then once this is built and deployed on staging servers and test servers and ultimately production servers, that this rule will be then enforced. Make sense?